All right, so we did several one triangle problems yesterday. Those ones are pretty easy, pretty self-explanatory overall. Again, we got to make sure we check if it's side-side angle, if it's acute or obtuse. Those are the thing we need to check first, and then we can proceed from there. We did this one yesterday. That was no triangle because C was less than A. If it had been one that was acute, obviously we would have found H and then gone from there. So we're going to start out with one. I'm going to go ahead and tell you it will be two triangles, but we're going to show why when we do it. So it's number 26. Angle B is 21 degrees. Side B is 17 and side C is 32. So this is where it becomes more critical about where you put things as well. Obviously, even just with looking at this is a side-side angle problem. Okay. B is acute or obtuse. Acute. So at the moment I have that B is less than C, so I'm going to refer back to my chart. So B is less than C. So I could end up with this scenario, or I could have this one. Okay, so just imagine I didn't tell you that it was two triangles. Okay, so then we're going to go through and find H with this formula. Let me get back to it. So in this case, H is going to be equal to C sine of B, okay, because of what letters I'm given. So then 32 sine of 21, and again, just a reminder, we are in degree mode because this is degrees. A couple of pre-cal has a quiz on basically the stuff that y'all just had a quiz on. They're just like a couple sections worth behind you, basically. And so they came in this morning and they're like, how do we know if the calculator's in degree or radian mode? I was like, if it's asking for degrees or radians. No. If there's a degree symbol or not. Oh. I was like, oh boy, it's going to be a long quiz.
Yeah.
And then I was like, have y'all done inverses yet? Like, I know we did them last year, but I was like trying to remember if we did them this year because I knew I had just done them with y'all and I couldn't remember. When I start teaching the same thing in like all the classes, and like today I start teaching the same thing in college algebra, I'm like, I'm going to be like, no.
Yeah.
But anyways. So what is H?
11.5.
11.5. So that means that H is less than B is less than C, which from our chart proves that we have two triangles.
I thought we were rounding to the nearest one.
Everything but H. H goes one place farther than whatever. So in the event that these numbers up here had been decimals, I don't know that they give you any, but if it was, we would go to two decimal places. If it doesn't just come out to be a nice even whole number to begin with.
Yeah.
But if it is whole numbers that we're given, we go to a decimal place because I don't remember if it was a problem we had or if it's one that's in the homework or that could end up on like a quiz or something, but I've seen it a couple times where like H came out to be like 11.4 or something, but B was 11. So if you rounded to, I think it was one of like the first ones we did yesterday where we weren't actually solving it, but it came out to basically be like the same thing. If we didn't put that decimal on there and you're like, oh, well, that's the nearest whole number is 11, that gives you a completely different scenario on the chart of what you have if they're equal or if one is less than or greater than the other. So yes, that's why we have to, for H only, we are rounding to probably one because I don't see any that give you decimals to start with, but if that had happened, we would go to two.
Oh.
So just kind of as a general rule. Okay, so I'm going to go back really quick to show you something on this chart. I was like, what just happened? It just like disappeared. So I don't know how well, because obviously in the notes video you can't see all the hand motions that I'm making. You can only see what's actually written here. But basically, we start with this line here and this one here. And so we're given angle A, side A, and side B. Okay? So angle A, it has to be, its opposite has to be side A. The other side we put here, okay? And we don't know what this side length is down here. But with two triangles, there's going to be two ultimate options. There's going to be one really big triangle, and there's going to be one smaller triangle that typically is going to end up with an obtuse angle for it. So basically, what it is that A is so big that when it is swooped around, it's going to end up intersecting at two different points. So that's what we're going to attempt to draw. What is going on? Oh, I guess it's like actually selected. Weird. Okay. So I'm going to draw it as one big one, and then, or like as the big one that we can see both, and then I'm going to actually separate them out into two separate triangles so that we can see what we're working with. So I have, nope, not that. Don't do that. Okay. Whoa. Okay, let's try this again. There we go. Okay. So that's what we have to start with. We were given, this is going to be angle B, was 21 degrees. Side C is 32. And then side B, it's going to hit, it's kind of imaginary, but we're going to say it's going to hit once over here, and then it's going to hit again somewhere down here. Not a right triangle. Let's try to make it not look like. Okay, something like that. And again, we don't know exactly. We're just going off of what we kind of think it looks like. And obviously my picture can't possibly be drawn to scale if that's 17 and C is 32, because it's clearly not. But we don't really care about that. And so then just for the purpose of having it, this is going to be angle C over here. This is going to be angle A, and then this is going to be side C, or not side C, sorry, side A down here. So I have, ignore what's written in the middle. I have one big triangle that I care about. So that's going to be my triangle 1 over here. Where I have, this is 21 degrees, this is angle A, angle C, and then C is equal to 32, B is equal to 17. Then I'm going to have, oh, and this is side A. Then I'm going to have another triangle that's much skinnier. Intended to look like a right triangle, but it doesn't really matter. This is a struggle. Y'all saw that too,
Yeah,
right?
it
It just disappeared.
tried to put a circle and then it just.
Okay, whatever. This is irritating me because this is not what it's supposed to look like. There we go. Good enough. So then we'll have angle C here, and so this piece here is coming out of this chunk right here. Okay, that's what I was trying to draw, and it's just, you know, not cooperating. So given information isn't going to change, but the other three pieces that were not given are going to change. Okay, so that's what we're going to be solving for, those three things for both triangles. Okay, so I'm starting with this big triangle here. So what pieces, or what can I solve for first? For this one.
Angle C.
Angle C. So I'm going to have the sine of C over 32 is equal to the sine of 21 over 17. So then I'm just going to do this all as one step because I'm multiplying by 32, and I'm going to go ahead and take the inverse sign just to save writing. Arc sine of 32 sine of 21 over 17. Forty-two degrees. So I'm going to do this I'm going to get rid of this now. So for triangle 1, angle A, angle C, and side A. And then I'm going to do for triangle 2, I'm going to go ahead and set it up. But okay. So angle C is 42 degrees for my first triangle. So then to find angle A, I can do 180 minus 21 minus 42.
117.
So 117 degrees. And then I need to find side A, so that's going to be A over the sine of 117 is equal to, again, I'm going to use given information, so I'm going to use B, so 17 over the sine of 21. So A is equal to 17 sine of 117 over sine of 21. So there's my triangle 1. Now, what do you notice about angle A and angle C here?
They're the same. Oh, none of the angles.
I was like, I don't think so.
One's acute and one's obtuse.
Yep, so this one is acute, this one is obtuse. Okay, now, the way that we find our other angle for this triangle, because otherwise if we start solving, we're going to get the same information that we just got. Okay, because I'm going to set it up as sine of C over 32 is equal to the sine of 21 over 17. Well, that's exactly what we just did, and you're going to get the same answer, and you're going to be like, oh, well, I guess they're both the same triangle, but that's not true, because we can look at this, and if I have to remember exactly what it is. Angle C, I have to remember the correct reasoning for it. Going back to geometry. I do this every time. Angle C is this acute angle here, but over here, it's going to be an obtuse angle, okay, because it's going to be big. So there's something about this angle and this angle adding up to 180. So we're going to do 180. So this all is for triangle 1. So for triangle 2, we do 180 minus 42 is equal to, is that 138? So my new angle C is 138 degrees. I have to go ask Miss Marshall what the reasoning is. It's something about alternate angles or something. I always forget which one it is because I don't use them that much. And so I'm like, no, I'm not going to teach geometry in the future. Sorry. But anyways, so that's where you get that. So you take the angle that was your original, your first original angle, and you do 180 minus that every time when you're doing two triangles. So then that gave me C. So then to find A, I still use, obviously, angle the 21 that was given, and I use this. So 180 minus 138 minus 21 is what? 21. So 21 degrees. Now what do you notice about A and C? Before we can. Yeah, so they switched. I don't know why I just did that. So they switched, and that's what's going to happen when you do the two triangles. So then now I just need to find side A. So A over the sine of 21 is equal to 17 over the sine of 21. So A is equal to 17 sine of 21 over the sine of 21, which that's just going to be 17 because sine of 21 divided by sine of 21, those are going to cancel, so that's just going to be 17. So triangle 2. They're like opposites, basically. So solve triangle 1 like normal. Then you use the acute angle that you found over here, okay, the one that's in the bottom right of your triangle. You use that one, subtract it from 180, and that gives you your new angle C for your second triangle. Okay, then once you do that, you can do the 180 minus. So finding the second triangle is actually easier mathematically. You just have to remember what you have to do to get there. And again, like I said, there's some rule of geometry that officially allows you to do that. I just can't remember what it is off the top of my head. So, any questions about that one? There's not, honestly, many in the book that are two triangles or no triangle. Other than like maybe the one where you tell that if they're going to be or not so much the solving of them. So I would just make sure you look over those if there's not one directly given to you.
I think that for the homework problems you gave us, there was one that had two triangles.
21.
Yeah. It was confusing.
Well, that one you're just telling if it is.
Oh, for that one we had to solve for the triangle.
Oh. I see that now. That's nice.
I was so confused why there were two sets of like answers in the back of the book. I was like, wait, I only came out with one.
Yeah, maybe go back and do 21 again now. I didn't realize that one was, I thought since I had gone up to, 24 yesterday, I was like, surely they'll be fine. Guess not. Oops. Well, now you can go back and redo it and understand what you're supposed to do. All right, so we're going to move into the area problem. So finding the area given this information, basically given a side-side angle set of information. Oh, actually not even a side-side angle. Given two sides and an angle, but not a side-side angle, technically. So I'm going to write the formulas out because in the notes you probably only had it written one way. I probably didn't write all three methods or all three formulas, but that way you see it because some people get confused. But it's literally just 1/2 AB sine C. So it's whatever two sides you're given times the sine of the angle that you're given. And that's always going to be the information that you're given. Or we can have 1/2 BC sine A, or we can have 1/2 AC sine B. So basically, those are the three formulas at most that you need. But if you know 1/2, whatever the two sides are, and the sine of the angle, you're fine. I had one class that wanted me for the triangle chart that told you how many triangles. They wanted me to write out every possible scenario that they could be given. So I, across the entire board, wrote every scenario that they could be given. And I was like, I'm never doing this again. So that's why I started explaining it a little differently, and it's been fine since then. But it was like one of the first years, and I was like, why am I doing this? Like, literally took up the entire board, writing every scenario for them. It's like, okay, this is a little crazy. Anyways, okay. So 34, C is equal to 96 degrees, A is 7, B is 15. So we just plug in the stuff. So 1/2 times 7 times 15 times the sine of 96. And then you just put that in your calculator. And again, I'm going to go nearest whole number just to be consistent with everything. So that the only thing that we're not doing nearest whole number for is H, basically. Area is 52. Let's see, we'll do one more. 36, B is 60 degrees, A is 19, and C is 14.
Don't we have to have units squared for area?
Nope, not for these.
Fun.
I won't mark it wrong if you put it, but you don't need to have it. Alright, so area is 1/2 times 19 times 14 times the sine of 60. $115. Could have done this one without a calculator. Because you know what the sine of 60 is. It's all unit circle.
Oh.
Well, you probably would have still needed it because it's the square root of 3/2, but it's a known value, so.
It's there.
Anyways, if it came up on a question where you didn't have a calculator on like an SAT or an ACT or something, you'd be able to figure it out. I don't think they would ever give you that on there, but you know,
Hope not.
maybe a Jeopardy question one day. Be like, what is 115? All right, so any questions about any of that? Or any questions about what you had yesterday in the homework? Were there any other than the 2 triangle one that were confusing? Okay. So I stopped at 21 yesterday, right?
Yeah.
Okay, so 27 is one where it says to basically describe and correct the error. What I usually say is solve the problem and then explain what they did wrong, because I think that's the easiest way to do those problems, because you need to fix their mistake. So that's usually how I say to do those. Anyways, and then 31 and 35 for area problems.